Hi, my name is Mr. Chonya. Welcome to my study room. Today we are solving objective questions 18 and 19 of the 2023 WASSCE Elective of Further Math paper written by Ghana. I choose to put these two questions together because they require the same understanding to be able to solve, and that is quadratic equation. But the first question is actually quadratic inequality and not quadratic equation. But the question 19 is quadratic equation. But since both of them are quadratic, that's why I put them together. So let's move straight to the first one, which is question 18. And it reads that find the range of values for which 2x squared plus 7x minus 15 is greater than 0. I said earlier that this is a quadratic inequality question. And if graphing calculator were to be permitted on this exam, we will just get onto any graphing calculator, for example, Desmos, and then put in this inequality and the shaded region becomes our answer. And I will demonstrate that quickly using Desmos. You just have to type www.desmos.com and then choose graphing calculator, and it gives you this. So I'm just going to put in my inequality quickly. And we have the graph of our inequality here. And I said earlier that the shaded region is the answer to the question. So that means that from this -5 to the left of it is shaded, and also from 1.5, which is the same as 3/2, to the right of it is also shaded. So my answer to this will be from here to the left of it, which if I'm writing, it will be x less than -5, which means all the numbers to the left of -5, and this is a broken line, so we are using less than. If for it to be a solid line, we use less or equal to. And then also the shaded region to the right is all the numbers to the right of 1.5, which if we want to write as inequality, it will be x standing for all the numbers greater than 3/2, which is the same as 1.5. This is how easy it would have been if you were using Desmos or any other graphing calculator. You always consider the shaded region. But since graphing calculator is not permitted on this, we need to go back to solve it manually. And we'll start by expressing this as an equation, and that will be 2x squared plus 7x minus 15 equal to 0. And if you factorize this, you are going to get x plus 5 and then x minus 3/2 equal to 0. And if you equate each of them to 0, you're going to get x plus 5 equal to 0, and then x will be equal to -5, or x minus 3/2 equal to 0, and x will be equal to 3/2 positive. And I just factorize this directly because, number one, this is elective maths and we are expected to have known how to factorize already. And then for those who are not sure how we did this, I have a very concise video on how to factorize quadratic trinomials, and I'm sharing the link with you at the top right now, and you can also get that in the description of this video. The title is Factoring Quadratic Trinomials Using Slide and Divide Method, and you can go there and you see step by step how to factorize quadratic trinomials of different forms, and I use different examples in doing that. So let's go ahead and solve our question further. These answers here mean that we have a quadratic graph with -5 and 3/2 or 1.5 as the boundaries or the x-intercepts of the graph. So let me try sketching that here. I have this as a number line, and then let me have 0 here, and I'll have -5 here. This is not drawn to scale though. and then I'll have 1.5 or 3 over 2, anyhow you want to write it there, but just make sure 3 over 2 is positive, so it should be to the right of the 0, and negative 5 should be to the left of 0 because it's negative. Then I'm going to sketch a quadratic curve, and then there are a few things I need to know. The first thing I need to know is the nature of the curve, whether it has a minimum vertex or a maximum vertex, and that can be seen here. Since the coefficient of x squared is positive, it means that our graph will be in the form of a U, so it will have a minimum vertex. So our graph has a minimum vertex since a, which is the coefficient of x squared, is greater than 0. It simply means our graph will be U-shaped and it will cross the normal line at -5 and then 1.5. Then after knowing the nature of the curve, we need to know which area we are going to shade. There are two regions, either the area below the number line for less than here, or as you can imagine, I'll be saying the area that is above the number line. Remember, we have two parts of the graph which are above the number line for greater than, and in this case we are using the area above the number line which is greater than. So you're using this part of the graph, the shaded region, which is all x values that are less than -5, and that will be written as x less than -5, or because it's not continuous, all the values greater than 1.5, which is the same as 3 over 2, so x greater than 3 over 2. And looking through the option, that is option B. And someone might ask, how do we know whether here should be less than or equal to, or greater than or equal to? That will be determined if this were also greater than or equal to. As for less than or greater than, you tell depending on the area you are shading. So these are all values less than -5. That's why we use less than. These all values greater than 1.5, or all values to the right of 1.5 on the number line, they are greater than 1.5. And here to the left on the number line, they are less than -5. So that's how we use the bar. As to whether you should use a solid or a bar under it or not, the bar will be under it if there is a bar under the question. So that's just what I want to say. And then again, for more on how to solve quadratic inequalities, I'm sharing a video with you right now, and it will also be in the description of this video. It seems I use about 3 different ways of solving quadratic inequalities, so you can check that. It used different approaches aside what I just did here, and I'm sure it will add up to your understanding of this concept. So the answer to this question is B. We move on to the next question, which is question 19. And question 19 reads that if alpha and beta are the roots of x squared minus 2x plus 1 equal to 0, find the value of alpha squared minus 3 alpha beta plus beta squared. This is a quadratic equation with A, which is the coefficient of x squared, being 1, B, the coefficient of x being -2, and C, the constant term being 1. And in solving this question, we are going to use or apply the symmetric properties of quadratic equations, which says that if alpha and beta are arbitrary roots of a quadratic equation, then sum of roots, which will be alpha plus beta, will be equal to -b over a. And then product of roots is roots, which will be alpha beta, will be c over a, using this a, b, and c. So we are back to the question now. you have to find the value of alpha squared minus 3 alpha beta plus beta squared, right? Good. So this alpha squared minus 3 alpha beta plus beta squared can be rewritten as alpha squared plus beta squared minus 3 alpha beta. I just rearrange them, bringing alpha squared plus beta squared closer to each other because I want to express this here in a way that we can have sum of roots and product of roots so that we can substitute into that. That's the reason for the rearranging. So you can see that here we have something that looks like sum of root, and then we have product of root clearly here. But then I'm coming back to this part of it, which is the sum of two squares. It's not the same as this. This is an identity that if we should cast our mind back to the elective math class, we will remember that alpha squared plus beta squared is the same as alpha plus beta all squared minus 2 alpha beta. So in place of this, we are now going to substitute this. So this whole expression, which is what we are solving for, becomes alpha plus beta all squared minus 2 alpha beta, which is for this part of it, then minus 3 alpha beta. And that will be equal to alpha plus beta squared, or 3 alpha beta. I forgot to bring the beta. So this and this are like terms. So when we put them together, we are going to have negative 5 alpha beta. So minus 5 alpha beta. Now we have the whole reason why we are doing this figured out. So we have the whole of this expression now written as sums and product of root. So we are now going to substitute this and this for the sum and product respectively. So sum of root is negative b over a. B is negative 2 over a is 1. And that is just for the sum of root. And we have negative of that for the sum of root, and the whole of this squared. Then minus 5, c is 1, and then a is also 1. So this side becomes positive 2 squared minus 5. And that will be 4 minus 5, which will be negative 1. And when we look through the options, that is option B. So the answer to this question is option B. And that is where we bring today's lesson to an end. I hope this has been of help to you. If yes, then kindly consider subscribing to this channel for more videos like this. Till we meet again in my study room. Bye-bye.